Good evening, ladies and gentlemen. Welcome back, Algebra 2 students, and today we're going to learn how to rewrite an exponential function given a function, right? So here we can tell right away that this is an exponential function. The only problem is, if we zoom in, is that we actually have a fraction, right? We have t to the power of t divided by 28, and we notice that our exponential functions do not look like that, right? So here again, another reminder about what our exponential functions should look like, and that does not have a fraction in the exponent. So that is the main issue that we're going to be dealing with. So let's go ahead and start reading. The amount Y in grams of the radioactive isotope chromium-51 remains after T days is the function Y equals A times 0.5 to the power of T divided by 28. So we already knew that A is the initial amount, right, in grams. What percentage of chromium-51 decays each day? So we're going to basically solve for R. Remember, percentage reminds us of R. That is exactly what we're solving for. So we have to get rid of the divided by 28. Now the logic that they use here is power of a power property. Now what I want to do at this very moment is I want to help you all remember exactly what I'm talking about. So let me go ahead and enlarge that. Let me go ahead and help you remember power of a power property. So here we have a to the power of 3 to the power of 4. So what does that equal? That equals a to the power of 3 times 4, because as an exponent to an exponent, you have to multiply, right? So here you have a to the power of 12, right? Because 3 times 4 is 12. Now we go on to the next logic, which is using fractions. A to the power of 1/3 to the power of x. Here we would get the logic is a to the power of 1/3 times x. So here the logic becomes where a is equal to x over 3. So we're going to try to reverse that. That's the logic that it's asking us to do, is to get rid of the fraction so that we no longer have that fraction. So we're going to eventually get here. And if all of you can see the shortcut, if we have t here and 28 here, then we can just simply write t here and then 1 over 28, right? But for those of you who want to understand the logic, here we go. So here we have a to the power of t divided by 28. Here, the next step, the split that we're doing, right before we got to that step, what's the following? Is to write t times a to the power of 1 over 28. So now we're allowed to separate them and get a to the power of 1 over 28 to the power of t. So that's exactly what's going on here. So here we get 0.5 to the power of 1 over 28. So now what I want you to do is I want you to go ahead and use the scientific calculator to find out what that is. So we go and write down 0.5 to the power of 1 over 28. So here we get 0.975. So I'm assuming that they want you to round. 5 does round up, so we get 0.98. So let's go ahead and let's go back to our example. They actually use all the way up to the thousands place, right? We have tens, hundreds, thousands, 10,000s actually. Let me go ahead and fix myself because I said that wrong. We're actually in the 10,000 place, and here we're going to write this in the as the exponential decay model, because we noticed that this number is less than 1, so we knew already that we were going to have decay, right? Even says in the word problem, but just a reminder, here we have a number less than 1, so we're going to write 1 minus r is equal to that number right here, right? So by the way, let me just go ahead and remind you, this is exactly where it says decay. So you already knew in advance that you're going to use this format. So if you write 1 minus r is equal to 0.9755, you actually are able to solve for r. Now, for those of you who have been wondering how to do that, let me go ahead and help you. If you write 1 minus r is equal to 0.9755, in order to solve for r, we have to add r to both sides and subtract 1 minus 0.9755. So let me go ahead and help you do that. Let me erase what we had before. 1 minus 0.9755, and we actually get that r is equal to 0.0245. So we go back to our example and we can tell that 0.0245 can actually be changed, because that's its decimal format. It can actually be changed into a percentage. Remember, you start where the decimal is and you move 2 spaces to the right, so you go 1, 2, and you get 2.45. So that is the end for this explanation. The next thing that we're going to do is compound interest. Okay, have a good night. See you all later.